and I'm going to make sure you can share your screen. And have you guys ever met Dave Schlichting?
I don't believe so.
Oh, well, you're in for a treat. Dave, you want to introduce yourself,
Yeah,
please?
how you guys doing? Dave Schlichting. I am out in Colorado. I'm kind of Glenn's counterpart on these projects. So looking forward to seeing what you guys have developed here. Looks pretty cool.
We're glad to show it off. So we are the trash ejector group from Fairport Central School District, specifically Fairport High School. I'm Jackson Newcomb.
I'm Dean Blanchard.
I'm Gavin LeCount.
So we are also specifically the airlock group. After us, we have our counterpart, our ejection group, who is just off camera.
Okay.
This is our prototype of really just the external mechanism, kind of sort of in a way an exoskeleton in a sense. But we have the entry of the trash, the muzzle cap, and aka the outside exit, and then the in valve. I don't know if you can read it. In.
Yep.
On the other side, we have out, or the air to be put in and put out. So the idea is that we would have some sort of pushing force. It would be twisted out of the way and retracted. It would fire, then it would re-extend, reposition itself, seal back up, which then allows for the top to then be opened, reloaded, and closed very quickly and simply.
All right. Now, you say there is another team that's collaborating with you?
So the project originally was proposed as one solid project, but in the not portfolio, but my brain's blanking on the word. But
in the project list online, it said that one team was going to be airlock and one team was going to be ejector.
Okay.
So,
Yeah.
Because we had enough people, we split our group into two different subgroups.
Okay. All right. Very good. So this is an interesting design. Let's go back to opening your outer door, right? Mm-hmm. You have a mechanism there that you've kind of got some copper piping connected, et cetera. Is your intent that this would all be done manually, or would there be an iteration developed later on that has a power source for controlling that outer door?
So ideally, yes, due to our limitations and our limitation on knowledge and resources, we do not have what is necessary to implement an electronic version.
Sure.
But ideally, for an actual full-scale NASA launching iteration of this,
okay,
we would have it be electronic and hopefully wireless if possible.
Sure. Okay. And that's perfectly fine, guys. I assure you, most of the teams that I have been looking at are doing something similar to you. Obviously, getting motors and powering this up, et cetera, increases the complexity quite a bit. Now, when I'm looking at this, kind of in your central tube there looks to be something that's coming out of the central tube kind of towards me. That. Describe what its purpose is. Is that to evacuate the cylinder?
It shows you just to get air. There's one on the other side to get air in and out.
Okay. All right. Perfect. I just wanted to clarify that. So describe to me where the position of the wall of the spacecraft, the bulkhead of the spacecraft is in relationship to your overall design here. Is it close to the door? How much of this would be external to the spacecraft and how much would be internal?
Ideally, somewhere around here, but it really just matters where the in and out.
Right. Understood.
That can be adjusted really along anywhere. Additionally, our plan is also to shorten the barrel due to a problem that will be touched on later upon by our launching subgroup.
Got it.
Do you want to move to the slides?
So, guys, let me make a suggestion. As you're moving forward, what I would do is place something as a representation of that bulkhead, right? It could easily be just a thin sheet of plywood or something that you can kind of surround it with, so that there is a spatial relationship. Where is the wall of the spacecraft? It's also something that if you kind of cut it with a flat bottom on it, it will stabilize your system. Right now, you've got things that can kind of rock back and forth a little bit, but it's just nice to know how much of this is internal and how much is external. Okay.
So that's
very good.
That's good. Thank you, Dave, for that. It's really important suggestions. I really like them. Mike Bennett has also joined us from NASA HUNCH, and thank you, Mike, so much. Will you guys show us again, and I would like to see it again, how that opened and closed your external hatch there?
Quick overview of how it is, because I got the soup can here.
Okay.
So the astronauts would twist and open, or just pull and open, put the soup can in, it would load, we would put the plug back in.
Got it.
The breech door would be pushed, rotated out of the way, and retracted, which then you will see the can has perfectly aligned itself.
Okay.
Yeah.
Already, not fully through the tube, but partially through. And then the can would be fired. Then the breech door would be pushed back into its forward position, rotated back, and then once again closed and sealed.
Got it. Very good.
Very clever. Go ahead, Dave.
So, guys, I assume that the other team is going to maybe talk about the mechanism of getting the can out of the cylinder.
Yes.
Okay. So, one more suggestion on your end. And this is something that Glenn has kind of updated this with recently. Try to, you want to have a mechanism, and again, because you're really not trying to wire this thing up and use sensors and motors, etc. You need to have some type of a mechanical communication between that inner door and outer door, right? There has to be a way that will prohibit an astronaut from inadvertently, for instance, opening that inner door while the outer door is open, right? Spontaneous decompression would not be good. So it doesn't have to be overly complicated, but it is something that we're looking for, okay?
That's actually important. And though the astronaut is going to open the door physically himself right now by pushing that, right? He could forget that he left it open and put another piece of trash, another can in there. So that becomes really important. And
absolutely.
And Dave's comment about showing where the outside to the space station is, that's real important in this project too, because when you moved your external door, it does not go inside the space station. The external door stays outside the space station. So that you need to show somehow. because that's really very important in your particular case, but in everybody's case. I don't have any suggestions on how you can safeguard the astronaut from making a mistake of putting some trash in when the thing is open, but try to think of the simplest way possible, the fail safe way as much as possible.
Yeah.
And it can be mechanical. It does not have to be electronics. Does that
Correct.
make sense?
In
Yeah,
fact,
yeah.
I'd probably recommend it not be electronics because they can fail. So a simple fail safe, maybe even just a spring-loaded indicator. So if there's a vacuum, it pulls it down, shows a different color even, or moves the dial. Just something simple. Yeah.
Yeah, guys, it could be something as simple as, when you think about, like, for instance, a gate latch that basically pivots back and forth. You could have something put in there that, like, physically prevents you from opening that inner door when the outer door is open, right? Don't over engineer it. Don't make it too complicated. But again, that's a vital part of a design here. So you just want to have something that acknowledges you're aware of this and have created a mechanism that prevents it. Okay.
Okay. And so thanks for those comments. And Mike is absolutely right. If you can make it as simple and not make it electronic, because who knows if the power will fail and they still need to have get rid of the trash. The other thing, I want you to hold your project up again, and I'm a little worried about the copper tube, so that we would need more than just the round external hatch, but we also need a piping going outside of the space station. Is that correct? Is that how you're designing it?
So ideally, I mentioned earlier we would NASA created version of this would be wireless and would have some sort of like Bluetooth like transmission system.
Mm-hmm.
So the breach door would completely be external if possible.
Sure.
With only a motor and a little bit more, but not much hardware and electronics. So we can eliminate the outer piping going in and out. So there would only be the one hole in the hull of the ship, and that would be the ejection.
Okay, so really, that's a great answer. Thank you, because then it really would just be the outside hatch that's going to be exposed to the outside. But I was thinking, could you put that piping inside the cylinder too? I don't know.
If the cylinder was big enough to house both the external and the trash at the same time, then yes. Though right now, the interior can only be able to, it either has the trash in it, or if the pipe was inside, the trash would be stopped as soon as it goes down.
Yeah, because I like the way it opens, and I like to have redundancy also. So I like to have it manually be able to open, as well as, a future electronically be able to open. And 3D printing it, since you're using PVC pipe, right? But 3D printing it, you could make a cylinder with a little bump on it that could keep this inside too.
Additionally to your earlier comment about the manual the redundant, well, not redundant, but backup lock to prevent both hatches from being open at the same time. We are working on that currently.
Very good.
In our slideshow, we have a slide that we're not sharing at the moment. I just realized. We have a slide of what's next, which highlights more consistent sealing with our prototype, because when I first opened the breech door on the outside, you could see it. When I was trying to close it, it was not fully aligning. So that is a little bit of an issue that we got to fix, followed by integration of
Got
the
it.
launching mechanism. So
Yeah.
with that, we're going to hand it off to the launching group.
Well, do you have a slide show for us, or is it with the other group?
We do have a slideshow.
That you can show us?
Yes.
Yeah.
Okay, well, we'd love to see that too.
Yeah,
All
why
right.
don't you go ahead and share, and then when you're done, we'll unshare and take a little closer look at the prototype again.
Okay.
Other one.
So
That one.
our yeah, we have so go to the next. So this is the original. Oh, sorry, Dean.
Yeah. This is the original Y fitting. It's basically what we have here, except this one's just more curved since the cane wouldn't fit down a regular Y fitting. The one we have on our left is the Y fitting we made in CAD, while the other one on the right is just the Y fitting we found online and used it for inspiration to make the CAD.
Very good.
Oh, I didn't see the message there.
These are just some CADs of some locking mechanisms that we have used in our earlier prototypes or our current prototypes, such as the cork, which is what we have right now. The threaded plug is something we had for our first prototype, where we had a screw-on sort of cap that was airtight.
So the nozzles, since we don't have NASA grade nozzles, we went to Home Depot and Lowe's and just got a simple ball nozzle, a ball valve, and a simple nozzle, which we actually drew inspiration from the Bunsen burner connectors in our chemistry labs here, with the bridged connection point.
And this is our prototype evolution. We originally started with sort of like a breech door, as we continued same with this one. The only problem with our original design is we had backloading, which would get in the way of the ejection system. We have to take that out and then insert the trash. So then we switched to top loading by seeing prototype 2. It's basically the same exact thing. Only thing changed was the loading of the tube. And on the far right, we have basically our prototype right here. The only thing's missing is the in and out tube. And it finally has this sort of, I call it like a slide rail. You just push the thing out and opens it.
So this is just another showing of the breech cover and muzzle cap, which we've shown off the videos of the breech cap and muzzle cap.
But you're showing so
Next. So then what are we doing next? I talked about the inconsistent sealing and combining the two projects, and then also mentioned the safety mechanism, which you guys talked about a lot. And we're really running tight on time, so we are going to be transitioning to our launching group.
Okay, great. Nice presentation, guys. Thank you very much.
Enjoyed it, guys. Thank you.
Yeah, nice model. And I am recording this. So I'll put it online and Glenn can see it. I'll make sure he gets the link.
Hi.
Hello.
We're the other half, the actual ejection part. I'm Zoe Ibbotson.
I'm Emerson.
And I'm Sam.
Yeah.
So this is our prototype. It's basically just the ejection part, so we don't have any sort of airlock thing, but this actually can really nicely fit into their thing.
Mm-hmm.
So yeah, you can take their thing and ours can actually just fit right in there.
Oh.
Okay.
So, yeah. Anyways, we have a spring-loaded mechanism in here. I can just show it working. So this isn't great for pulling it back right now, but we are going to have a method to attach it to this pushing plate in here. So right now you kind of just have to push the can in. And then this is actually an old spring scale rod that I cannibalized for this. And then you hold onto this here and then let go, which will allow the spring to release, and the can comes out. Doesn't go too far because our spring is not very strong.
Mm-hmm.
And then I can take this apart just to show you the insides. Take a second. So this is what's inside it. We have this cardboard pushing thing, and then we have our spring just on here. So what happens when you pull it back is this compresses the spring, and then it just gets released.
Okay. When in your design with the other, I know that the other team that's building the housing was suggesting that they're going to try to shorten things up a little bit. Is that correct?
Oh, yeah.
Okay. So, the amount of travel that the trash has to go through the cylinder is going to determine a lot in terms of how strong or how much force your spring has to apply to it. Okay. I've made the suggestion to a number of groups as well that if it will help facilitate, you can add what I'm going to call a cheat to your design. Now, here's the deal. In space, you're in microgravity and you've already created a vacuum, right? When you've evacuated the atmosphere from that launch tube, you've opened the outer door. So effectively, there's virtually no resistance to the movement of that can. But you guys are fighting gravity, right? Mm-hmm. We are on Earth. And when you put that can into the tube and push it, you're going to have friction as it's going out. You can provide some type of lubrication in there. This is not something that would obviously be a part of the actual design, but in order to try and compensate for gravity, you guys can add something. You could use, for instance, if you had a small channel in the bottom of your ejection tube and you put something like some BBs or something in there that the can could roll on, you might even be able to just take some graphite powder, which is a great lubricant, and just lay a small little layer on the bottom of that tube. It will help to facilitate that thing getting out. Now, again, we're recognizing that you're designing something that's intended for space, and you got to demonstrate it on Earth with, the acceleration of gravity here, which is pretty strong. So just a way to try and make your design a little bit easier. Okay?
Yeah, okay. That seems like it'd work. Definitely worth trying.
Yeah, and trust me, it's you're just doing that to compensate. We understand that this would not necessarily be a part of your final iteration. Okay?
Yeah.
All right, very good. I would also recommend that in your system, the trash or the soup can is going to be in the launch tube, and then you're going to have to pull that spring back and release it to give it its forward momentum. You may also want to consider, just as a backup, having something that guarantees that can will be held in there and can't get inadvertently launched early. You know what I mean? It could be something as small as a little pin or something that would correspond to a latch that could be released, and then you can fire the trash. It's simply a way of acknowledging we want some redundancy. We want some things that are going to guarantee that things don't go off unintended, et cetera. Especially, you don't want to launch this thing with that outer door or closed, right? You don't want to fire something into that airlock door. So that would just be another little tweak that you guys could add to your final iteration.
We actually have something like that. Do you want to explain it?
Yeah. Let's go through our presentation first.
Sure.
Do it in a brief minute. I have a video of it working that I can put in slow motion here.
Okay.
It's nice because you can actually see what's happening. So this is, the thing. You can sort of see and hear that the pushing plate is right about there.
Uh-huh.
It's not incredibly transparent, but you pull it. Actually, I had it pulled back. But yeah, it just pushes it out. We are able to get it to actually go decently far. One of the other things is our spring bends when we try and actually pull it back. So we are probably going to get a new spring that actually springs better than this spring.
Mm-hmm. Cool. Actually, your ejection speed looks pretty nice, I think.
Yeah. Just hit escape. There you go.
All right.
Okay.
So I was in charge of the pullback mechanism. The idea is to have consistency in how we're launching the trash out. So we use springs, and my first idea of compressing spring was to use like a lever or something, or pulling something down. But I eventually moved on to a wheel, because in space it's easier to use wheels. So how it works, so I have CAD drawing right here, color coded, and the idea is you turn the wheel, it turns gears, it pulls back the spring that's attached to it pulls back a gear rack that's attached to the plate that the trash sits on. You pull it back. We're using a 3-to-1 gear ratio to make it easier to pull back the spring. And yeah, here's a closer look at the CAD design. So I have a bit of a simpler design here to show how it works right here. So the idea is that the gears turn, it pulls back the plate, then you put a lock in there so it doesn't launch. Then you move it and it launches.
Nice idea.
Okay, so we had many ideas to spin the trash, which would actually make it go in a straighter direction when we actually shoot it out. The first idea that we heavily looked into was rifling, which is used in the barrels of guns. So as you can see, we used a cardboard model first, but it didn't really work out because cardboard compresses, so with enough force you could just like shove it through. But we also did like a CAD drawing of it. But when we actually tried to move it to our model and our can, we realized that it would take too much, I would need too much force to actually push it through, and our model wasn't strong enough. So we switched ideas, and we're in between a few ideas right now. We haven't really settled on one, but the main one that we're looking into is actually spinning the pushing plate while it's being ejected, so the can would actually spin when it's being released.
Okay. Okay.
One of our previous ideas that we decided not to go with was a scissor mechanism. How it works is it has its like arms are crossed, and when they're pulled apart, it retracts, and when they're put together, it extends it out. There was multiple different ways of extending it, lever, gears. We decided to go with a combination of springs and fixed point. So when you would pull it back, the spring is in tension. So when you release it, it wants to shoot out and actually push the can. There's multiple pros and cons for this. Some pros is actually NASA used it in the TAL during the Skylab. It's also very strong. However, we decided not to go with it because it wasn't as simple or compact as the idea we ended up going with. So we just had a few trial runs using 10 newtons of force to actually pull back the arm. We averaged around a little over 22 centimeters from the can to the pushing plate. And then it's just a video of it like working. You can just see how it's like when you pull back and then the spring shoots it out.
Mm-hmm.
And some links that we used. And yeah, thanks for listening.
Any questions?
Wow. Hey, I got to commend you. I like the fact that you're already testing. I love to see data that, is reproducible. So keep that up. I like that a lot.
Yeah, and it actually is a very good engineering process because you had an idea. I remember that idea, and you tested and said, "No, we're going to redesign." So, tested and redesign. So could you put your thing back into the I want to see where it fits in, how it fits in.
Okay.
While you're doing that, this is a question for Mike. If you're still on there, Mike.
Absolutely.
Yeah,
The trash airlock on ISS that Nanorex built, does
In the
that still
Bishop, yeah.
get launched with a rotation on those bags, or is it just like a straight catapult?
I don't know, but in the videos I've seen, I think it's just a straight catapult.
Yeah, I do too. And so I commend you guys in thinking about applying some rotation to the can as it's coming out. Obviously, the concept of rifling for guns has value. A great deal of which has to do with the fact that you want to get as straight a trajectory as you can, and you're firing into a fairly thick atmosphere. Don't forget that you're launching this effectively into a vacuum. There's really not a lot there. And although things have evolved a little bit since Newton's time, Newtonian physics of the trajectory of an object, an object in motion will travel in a straight line unless it's acted upon by some force. The only potential factor that might influence that would be the gravity of the spacecraft itself. And I don't think that that's something that you need to concern yourself with. So if you find trying to impart a spin onto this is complicating your thing, don't do it, right? Just stay with having this thing come out in a straight line.
I agree, because you're actually losing some of your pushing force to actually spin it.
That's
So you're
right.
you're decreasing some of the efficiency that perhaps you need.
Exactly. Okay. So back to your lunch. Let's see you load that in there one more time. I'd like to take a look at that as well.
Into the other team's product?
Yeah.
Okay.
Uh-huh.
So this other section here is where our launcher goes. This is where you put the cannon.
So how's the can going to go down there? Because you're in a spaceship that has microgravity. It's not going to go down. It's going to float.
Yeah.
Do you want me to answer that? Because that
Sure.
is part of our.
Sure.
So,
No more.
yeah. So the idea is that astronauts would, in the zero gravity, astronauts would open up the port and then apply some downward force. And since there is no really resistance or friction, the downward force would continue all the way down. It is until it is slid nicely into the barrel.
Uh-huh. So how are they going to apply downward force? Because it's microgravity.
Again, well,
They're going to push it with their arm?
yeah, they would just push it with their hands. So that actually comes into why we also are shortening the barrel.
So if you're putting it down in here, you come across another problem, which is it's probably just going to bounce back and forth. So
Very
that's
true.
I was emailing Flo about potentially using magnets to keep it on the flat plate, but that's probably not going to work because magnets are generally not great in a spaceship, and also the actual trash would be ejecting doesn't have any magnets. So we just started looking into potentially putting a pillow on our plate so that you're able to basically extend the time of the collision between the plate and the trash so that it would be able to stop against that pusher. We haven't actually had time to put that into our prototype, but we are working on that.
Okay.
So why do you need this loop? Why not put the trash right in before you put your attachment to the thing?
We generally wanted it so that you wouldn't have to take out this whole ejection system because it would be fairly complex. We would potentially have gears on there and a gear rack, and it would maybe get broken pretty easily. So
yeah. I understand that. That's good answer. Good answer. But maybe just make a opening, a hatch there to put it in right in front of your attachment instead of this. I'm just afraid the little, curved thing is going to cause problems with microgravity. What do you think, Dave and Mike?
Well, I see the point, and actually the comment that you made about if you're pushing this in, there will be a tendency for it to keep going, right? All the way to the end of that launch tube. And that means it's going to hit that outer door. And I wouldn't want to see that happen, right? I mean, that's an airlock. You don't want to be banging anything into that door.
And would there be a rebound where it tries to bounce back like you talked about?
Exactly.
Also, I was just curious, if you're doing a CAD model, have y'all drawn it with the can in there to see how much clearance you have on that curvature?
Step in frame? Yeah, I'm just going to step in frame with. So I'm going to answer a few questions real quick. So I will move in right here. So starting with the curvature, we have, yes, especially with the original Y tubing. We have been having, specifically Gavin, my group mate, who has left. We were having issues with getting the curved structure of our new version. So we are working on getting a proper CAD using the curved version. So not again, but we curved it and switched from the normal Y fitting to now a curved due to the complications of said clearance and trying to get the can to go in. Okay. So there was not a lot of wiggle room for clearance in just a regular Y. So we switched over to the curved, along with it also more nicely fits the horizontal barrel of the launching system. Okay. So another thing you guys mentioned is having the launching component be able to be removed and just putting the can in. So if you look at the back, like Zoe said, that's where their attachment will go. Mm-hmm. Ideally, we would have a separate canister that can, if possible, be removed for repairs and fixing. That can just be slotted in right there. And ideally, this is what our final prototype will look like on the outside. And inside of this little cartridge will have their prototype inside. And then twist for easy removal, for editing, and fixing any damaged parts.
Got it.
So I like the removal part because actually they might want even to change the spring out or something, and you're making it very easy to remove. My question is about making it too hard to put the trash in it.
So the goal of it being there isn't a clearance issue putting it in here because we've
ensured there's enough space for it.
Yeah.
But I think one of the reasons why we're not just having a hole cut in the top where you put it in is because that would mean the astronaut has to get fairly close to the actual ejection system, which potentially means going into the wall depending on where that is. So it would just be a bit easier if they had a tube they could sort of push it into, rather than having to go right up to the ejector and put it in. Right?
Yeah.
Okay.
And I'm already blanking on what you asked. I am so sorry.
It happens.
My memory is not the best right now.
No, that's a good answer, right? So that's a good question of how exactly is this going to be stationed on the spaceship, and will it be easy to get to? I always pictured it that it would just be sticking out of the wall. That whole thing, that big long thing, would be sticking out of the wall, except for where the hatch is. That's going to be outside of it. But I don't know, quite honestly.
Got the idea of why fitting from the proposal of the project. There are images in it showing a previous airlock system where canister is actually implemented in the ground. So
I saw that one.
So that's where we kind of went with the Y, and now especially the J curving.
Yeah, I saw that in Skylab. They had that. But I wasn't picturing these to be in the ground. I was just picturing them to be on the wall. I don't know, Dave, where were you picturing it?
Well, and Mike can join in on this as well. You're in a spacecraft. Is there, by definition, a true floor or wall or ceiling?
That's
the
true.
Spacecraft is going to be a cylinder, so it could ostensibly be positioned anywhere that, as long as it's, going, from an internal compartment, to the outside. I think that what you guys are hearing during this meeting, though, is some concerns about the design of loading this in through that curved tubing. And again, if you think about the amount of space and volume you're occupying for that versus simply having a latch or a hatch with, let's just say for a minute, with hinges on it that opens up and you can put your trash directly in and then close that back down, you're eliminating these concerns about how are you going to push this down into a tube, and are you going to get any rebound? Is this thing going to have a tendency to kind of be bouncing back and forth, et cetera? There are concerns there. And if you can resolve that by simply eliminating that curve piece and putting your hatch on the side of the launch tube, then that doesn't become an issue.
Mm-hmm. But
okay.
I like that you have thought of, well, this might be easier for an astronaut to put the trash in. That's an important concept. But as Dave pointed out, you got some issues with it. Solve those issues and you can keep your design, right? Everybody's just making a simple hatch, quite honestly. I like your design because it's thinking outside the box, but it has created some issues that you need to deal with. And maybe dealing with those issues, how we also talked about having some kind of stop to make sure it doesn't go all the way out. Maybe that dealing with some of those issues will just incorporate that stop into it. I don't know. So don't give up on your design, but think how you can mediate these issues. Does that make sense?
Yep. Testing, guys. Demonstrate the validity of it, and that will go a long way. Because Flo's right. You're doing something different than what I've seen any other team do.
Right.
And that's a good thing, as long as you can provide the supportive data that says this is an efficient way of loading the trash in there, then you've got a strength. Okay.
Because you're making it easy. Your strength is you're making it easier for the astronauts to put the trash in. So that causes some problems. Figure out how to stop those problems. And while you're figuring it out, it will actually help some of the other issues that we talked about. So I don't want to discourage you. I want you to keep doing it, thinking outside the box.
Yeah, I don't think you'll discourage us.
Okay, good.
Okay. It's a cool design. I really like it a lot. You
Absolutely.
guys, and I want to say that I appreciate the fact that you are using readily available resources and building something from that, rather than just, going on Amazon and saying, can we buy a whole bunch of stuff and then build from that? I'm very impressed with what you've come up with so far. I'm convinced that your final iteration is going to look great.
And your testing looks great, and your data looks great. You're all on the right track here.
Absolutely.
Just keep it up. It's not an easy task, this trash ejector. So, but yeah, now you got me thinking it's going to be on the floor even. So who cares? Floor, wall, ceiling doesn't make a difference.
On the bulkhead. Anyway.
Yeah, exactly.
And this project is going to be on a spaceship going to Mars. And it's the Mars, which does have a little atmosphere that we're going to hopefully eject it into and have it burned up, so we don't bring trash to Mars. That would be terrible, right? Yeah. All right, any questions?
I do have a question.
Okay.
So we're using a kind of rod in here. Oh, sorry, that's blocking it. We're using a rod in this, but I was actually watching some of the other PDR videos, and I saw that a couple of the other teams were using string to pull this back. I was wondering, is there any substantial advantages to doing that, or is there any reason why that would work better, or why a rod would work better?
Can you say that again?
I talk fast.
No, that's fine.
No.
And
That's fine.
I didn't see and I'm sorry, I'm at a disadvantage. I didn't see the other designs, but using a string would probably have to go with a stranded cable. We wouldn't be able to use that, or maybe even a Kevlar, like a attachment, but probably a stranded. And the problem with stranded cables is after you use them a while, they start work hardening, and those fibers will get, separate, and all of a sudden you've got something sticky. But I was not able to see the other PDRs, but that's just a disadvantage of using cables.
Yeah, I like the way you have it without a strong metal something, and you can use whatever you can find in the hardware stores, right? But you still do need to do some research on what NASA should use for that rod, or NASA should use for the springs. And as Dave said, don't worry so much about how far that launches, because we're doing it in gravity, not microgravity.
Yeah, exactly.
Yeah, that answered my question well.
Yeah.
Awesome.
Keep doing what you're doing.
Yep.
Any other question? We good? February the 6th is your critical design review at RIT. It will come sooner than you think.
2 weeks. Considering we have 2 weeks off. 2 weeks off for Christmas, so it's going to be here before we know it.
So this is your last you get off at the end of this week, and then you have 2 more weeks off?
Yep.
Well, it just means more time for us to go home and work on our project.
Yeah.
Well, take some time off to enjoy the holidays. I hope you all have a wonderful holiday. But But you can't stop thinking about these things. I even think about them. Well, what could we do differently?
Exactly.
It gets into you, and I love that you're working so well together as two teams. It's NASA's all about teamwork, and you're accomplishing that right there in high school, which is really impressive too. So thank you for doing that.
Yeah, you can thank
Yeah.
Store
Great presentation. Great
Yeah.
presentation.
Very good.
Thank
guys.
you all.
All right. Happy holidays.
Yeah.
Happy holidays.
Enjoy your break. Happy holidays, everybody. Bye-bye.
Bye-bye. Bye-bye.
Happy holidays. Thanks,
Bye.
you in
Sure.
See you in
Yeah.
February.
All right, in February. Bye-bye.